All right, guys, we're going to take a look today at the top 3 mistakes made when solving two-step equations. So let's take a look at some examples of each common mistake. I want you to take a look at this common mistake. I'm calling it opposites, opposites, opposites. Take a look at the way this student does this problem and see if you can find the mistake. Did you find that mistake? Pause the video if you need to. All right, let's take a look at the answer here. So the mistake this student made was they didn't use the opposite operation to get rid of the plus 3. Remember, if we're trying to get rid of a plus 3, we have to do the opposite to both sides, which would be subtracting 3. So in this correct answer, subtracting 3 happens on both sides. The 2x comes down, and now we have a 9 instead of a 15. Then when we finish this out, again, we're dividing by 2 because that's the opposite of multiplying by 2. I do that to both sides to make sure my equation is balanced. And I get that x equals 4.5. Let's take a look at another example. So again, this is opposites, opposites, opposites. See if you can find the mistake in this student's answer. Did you see the mistake? Pause the video if you need to. All right, let's take a look at this answer. So in this case, everything was done well up until this point. So the first step was good. We subtracted 9 on both sides. That was the opposite of adding 9. Looks good. So now we have t over 3 equals 18. And what the student did in the previous mistake was they divided by 3 on both sides. But remember, we have to do the opposites. A lot of times we see that we're used to doing division as our second operation in our 2 steps. Okay, so we get so used to doing that we just do it without even seeing. But we only do divide because usually in the equation, this would be like 3t. If it was 3t, then we would divide by 3. But it's not 3t. It's t over 3, which means t divided by 3. The opposite of that is multiplying. So in the true answer here, we would have to multiply to get rid of the 3 in the t over 3 to just get t alone, isolate him. And then 18 times 3 gives me 54. All right, let's look at another common mistake. Here's common mistake number 2. Okay, look for the sign. All right, see if you can figure out what mistake is being made. Did you see the mistake? Pause the video if you need to. Okay, let's take a look at the answer to this. The mistake being made here, again, I call this look for the sign because the sign of this first term, negative 4x, is negative, right? So when I'm going to the next step, when I carry my negative 4x down, the negative has to come with it. If you do not do that, if you drop your negative somewhere along the way, you're really going to screw yourself up. Okay. The other part here is when we divide, we have to divide by -4. So this is another common mistake of dropping that sign. What is the sign of this term? -4. So when I divide, I'm dividing by -4. Let's take a look at another example of looking for the sign. See if you can find the mistake in this example. Did you see the mistake? Pause the video if you need to. Okay, so the mistake in this one was when they got to this step here, okay, they did good by adding 12 to the left side. They're trying to add 12 to the right side, but they're not checking in their calculator to make sure that this addition actually happens correctly. When we have a -50 and we're adding 12, we're getting closer to 0. We're getting a smaller negative number. So our answer should not be positive, and I don't add 50 and 12 to get 62. -50 plus 12 gives me a -38. So always check your work in a calculator, especially when you're doing any addition or subtraction of negative numbers. All right, here's common mistake number 3. It's called what's the symbol? Let's take a look at this, see if you can find the mistake in this work. Did you find the mistake? Pause the video if you need to. All right, so there was a trick question on this one because this student made more than one mistake actually, but it's along the general lines. Where is your symbols? That's the question. This student forgot to put this equal sign on this next line. So whenever you move from one step to the next step and you're rewriting your equation, you need an equal sign. Equations need equal signs. If you don't have that equal sign on your work, you're going to lose points. The second most common mistake that happens a ton is you start getting used to just putting the straight line across. And we think that's acceptable for this second step, just to have a straight line across, and that means divide. Well, if the straight line across meant divide, then look at your step number 1. Are you dividing there? No. So a straight line across does not mean divide. You need to have division symbols. That's why I have these slashes here. Those slashes mean divide, okay? Or you can have the division symbol, your choice, but the symbol needs to be there. Where is your symbol? Notice we still got the same answer, but our work was wrong on the first example problem. So let's review really quick. Opposites, opposites, opposites. Make sure you're always performing the opposite operations when solving equation. 2, look for the sign. Make sure that your negative signs are carried throughout all of the steps that they need to. And be careful when adding and subtracting positive and negative numbers. 3, what's the symbol? Make sure that when you're doing your work, you always have the necessary symbols written down on your work. The equal sign has to be on the line. Equal sign on the line, all right? And your division symbols, make sure you have those. All right, I hope this video is super helpful for you guys. Let me know if there's any other videos you would like me to do for any other work.